Alright, in this video I want to look at a slightly different way, or a very different way, of dealing with integration by parts requiring repeated integration. And this is kind of a shortcut method. So if we start with the integral of x squared sine of 4x dx, from our previous work with repeated integration, we see that we would have to apply integration by parts 2 times. What we're going to do instead is set up a table, a tabular approach. And to do this, we're going to make a column for our u variable and a column for our dv. So we start off with u, in this case being x squared, and dv being sine of 4x. Now we're going to repeatedly differentiate the u column and repeatedly integrate the dv column. So the u column is pretty easy. That's x squared becomes 2x and then 2, and we stop when we get to 0. Now the integration is a little bit more complicated. If you're not aware, we would have to do integration by substitution, but with sine of 4x it's pretty straightforward. With taking the derivative of sine of 4x, we'd get cosine 4x times 4. Well, with the integral, we're going to get negative cosine 4x and then divided by 4. That's for the first pass-through. The second pass-through, we're going to get the integral of cosine 4x is 1/4 sine 4x. So we're going to get 1/4 times 1/4 here. And it's going to stay negative because the integral of cosine is sine. And we already have a negative sign out. Now again, taking the integral of this, integral of sine is negative cosine, so this time it'll be positive, and we're going to divide by 4 one more time, and now we have 1/64 cosine 4x. So we stop at the point when the u turned out to be 0, or the derivative of u became 0. Then what we're going to do is make a kind of stair step down, starting from the upper left hand corner. So we go x squared to negative 1/4 cosine 4x, 2x to negative 1/16 sine of 4x, 2 to 1/64 cosine of x. And the signs for these will become plus, minus, plus alternating. And that's all you need to do. Then we're going to put it together. So I'm going to kind of move these things over to the right so that I have plenty of room, and we'll start to put it all together. We have x squared, negative x squared over 4 cosine 4x. Then we'll have minus a negative there, and it'll be 2x over 16, or plus x over 8, and sine of 4x. And the final one will be positive, and that'll be 2 over 64, which is 132 cosine of 4x, plus c, and we're done. So you can see that that was a lot less work than we did when we did repeated integration. So whenever you have to do repeated integration, this is definitely a good way of going about it. And I'll give you one to try. And you can pause the video and try to work that out, and I will give you the solution when you return. Okay, so this is how it works. We set up a column for the u and a column for the dv. U is going to be x to the 4th. And we'll repeatedly differentiate that. 4x to the 3rd, 12x squared, 24x, 24, and finally 0. And you can imagine if we were doing the repeated integration by parts the long way, this would take quite a bit of time. Now our dv is e to the negative x dx, and the integral of that will be negative e to the negative x. The integral of that will be positive e to the negative x, then negative, then positive, and finally negative. We'll make our stairs and the signs, positive, negative, and positive, and we're ready to put it all together. We start with negative x to the 4th e to the negative x, minus 4x to the 3rd e to the negative x, minus 12x squared e to the negative x, minus 24x e to the negative x, finally minus 24 e to the negative x, and plus c. And if you wanted to, you could factor out the negative e to the negative x, and that would leave x to the 4th plus 4x to the 3rd plus 12x squared plus 24x plus 24 plus c. And so that does it. That's whenever you have to use repeated integration with integration by parts, you can use the tabular method, and that will save a lot of time.